Let's start with the basics. When we add the RigidBody3D node, we get a warning. If we hover over it, we can see that it wants a collision shape added to it. Let's do that real quick. Go ahead and select a shape, which I'm going to choose the box shape. If we play the game, we won't see it, so let's add a mesh instance as well. There we go. We already have basic physics. There's quite a few settings. Some of the things I say here will be straight from the documentation. Number 1, mass, which, as the name suggests, it's the weight of the object. Number 2, physics material, which if we create one, we have multiple settings to play around with. These allow you to make something act like carpet or like ice, and like a ball or an anvil. Number 3, gravity scale. Well, this just explains itself. Number 4, center of mass, which has an automatic setting and a custom setting. Number 5, inertia. This is like mass but for rotation. The moment of inertia is usually computed automatically from the mass and the shapes, but this property allows you to set a custom value. Number 6, sleeping. This is true automatically when the object hasn't been moved in a while by physics, meaning it will compute less for more performance until something moves it. Can sleep disables or enables this behavior. Number 7, lock rotation and freeze. Lock rotation keeps the rotation from being changed by physics. Freeze keeps the object from moving by physics, and freeze mode static means it will not collide with other bodies along the path it was moved by code, and kinematic freeze mode means it will. Number 8, Custom Integrator. If true, the standard force integration, like gravity or dampening, will be disabled for this body. Other than collision response, the body will only move as determined by the integrate forces method, if that virtual method is overridden. Number 9, Continuous CD. Continuous collision detection tries to predict where a moving body will collide, instead of moving it and correcting its movement if collided. Continuous collision detection is more precise and misses fewer impacts by small, fast-moving objects. Not using continuous collision detection is faster to compute, but can miss small, fast-moving objects. Number 10, Contact Monitor. If true, the RigidBody3D will emit signals when it collides with another body. But do know that by default the maximum contact reported is set to 0, meaning nothing will be recorded. So make sure this value isn't set to 0 before using the signal. Number 11, Linear Velocity. This can be set in code under the physics process method, which moves it in the XYZ axis. Number 12, Angular Velocity. This can also be set in code under the physics process method, which rotates it by XYZ axis. Number 13, Constant Forces. Force does what linear velocity does, and torque does what angular velocity does, but instead constant like a motor. That is all of the different settings for the RigidBody3D node. If this was useful, consider liking the video, or maybe even subscribing. My small channel would benefit greatly from either of these. Other than that, I hope you enjoy, and I hope to see you in the next one.